Topic 4.1 is on ionic bonding. A lot of topic 4.1 includes things like how to name ionic compounds, but we already did that in our introductory unit, so we don't have to focus on that too much right now. If I wanted to describe to you what happens in ionic bonding, generally speaking, when you first learn about it, you learn that electrons are transferred. So let me show you what that means. If I were looking at sodium, sodium has one valence electron. Chlorine has 7 valence electrons. You know that chlorine has a high electron affinity, meaning it really wants to get electrons. And sodium has a low ionization energy, meaning it easily gives up electrons. The consequence of this is chlorine has a greater attraction to that electron than the sodium does. As a result, the sodium loses its electron and becomes positively charged. And the chlorine now has a full valence shell of 8 electrons and is now negatively charged. And positive and negative things attract and stick together. We call this an electrostatic attraction. If I were to ask you to describe the nature of ionic bonding, your description would be it's an electrostatic attraction between oppositely charged ions. When it forms a crystal, we end up with this really large regular pattern of alternating positive and negative ions throughout the whole structure. And a positive sticks to a negative, which sticks to another positive, which sticks to another negative, and it goes on throughout the entire structure. This is called a lattice structure. A lattice is like a framework or a network. And so it's a regular pattern. You may hear the term lattice energy. If you hear the term lattice energy, this is how it's defined: as the energy required to break 1 mole of an ionic compound into its gaseous ions. So in other words, if I have a high lattice energy, it's really hard to separate these atoms from each other. So this is, in effect, is a measurement of how strong the ionic bond is. A high lattice energy is going to give me a stronger ionic bond. And there's cases where ionic bonds would be stronger than others. For example, if I have calcium with a +2 charge sticking to oxygen with a -2 charge, that's going to be a stronger sticking than sodium with a +1 charge sticking to fluorine with a -1 charge. I would expect a higher lattice energy for calcium oxide than I would for sodium fluoride. There are some general properties of ionic compounds that you should know. Think of salt, like a salt crystal. If you've ever seen rock salt, that's a good way to think of it. Generally, these things are pretty hard, but they're also brittle, meaning if it breaks, it's likely to shatter into a whole lot of pieces. Generally speaking, we would say they have high melting points. Though you've probably melted sugar, you would encounter significant difficulty trying to melt salt. Do they dissolve in water? Sure do. Not entirely, not always, but they usually dissolve in water. And when they are dissolved in water, they will conduct electricity. In order for electricity to be conducted, we have to have charges be free to move. If they've been dissolved, when they dissolve, the ions separate into, for example, you learned dissolving reactions earlier this year. They break into those 2 ions, and those ions can move around and conduct electricity the same way that